Well, let's continue with probability, and let's look at using cards, mutually exclusive events. We're going to pick a card, and it can be an ace or a king. Well, the number of aces in a deck of cards is 4 out of a total possibility of 52 of them. And it can be that one or, which we add for the possibility of including kings. There are 4 kings in a deck out of 52. So that's just a simple 8 over 52, which reduces to 2 over 13, which you can make a decimal or you can leave as a fraction. We can also then look at slightly different variations, but they're really actually still the same idea. The number of face cards are 12 of them out of 52, and well, actually is 3 out of 13, because that's 3 per each suit, and then there are 4 suits. So we'll do the 12 over 15. Plus, well, if we want to get a 5, there are 4 fives that are available out of 52. And that's what, 16 over 52, which reduces to 4 over 13. All right, so 4 out of 13, or the decimal for that, is acceptable. Now let's look at it with dice. So if we roll 2 dice, what's the probability that we get a 1, or we get a 2, or we get a 3? And I guess it can be on either one of the dice. Well, the probability of getting a 1, well, there are no 1s that you could possibly get. So that is actually 0 out of 36. Well, we can add that to something. Well, let's put 36s for these others. To get a 2, there's only 1 possibility. And to get a 3, there are 3 possibilities. So it's 1 here, and there's 2 here, which means what we could get is 3 of these could come up, 1, 2, and 2 3s, out of 36 of them, which is 1 over 12. I'll leave as a fraction this time. Now let's take a look at when 2 things are not mutually exclusive. Okay, so here's an example of what that means with cards here. The probability of getting an ace, we know that that's 4 out of 52. Or the probability of, we replace it and we get a king. Oh, wait a minute, I need to change something on here. If not, that was copied from the other one. So we're going to do this with a change. Let's see, how would I best do it? I think I'm just going to cross out king. And we're going to keep it as the probability that it is a red card. I will provide the extra thing that I want to teach in this with this question. Now, red cards are the hearts and the diamonds. Okay? So that means that half the deck are hearts and half, between hearts and diamonds, that's half the deck. So the probability that we would get a red card would be 26 out of 52, because there's 13 hearts and 13 diamonds. But here is the problem that we have. The aces, the 4 aces, one of them is a club. I forget how to draw club well, so let's do CL for club. And then we have hearts. Red. We have hearts, and we have diamonds, and then we have, spades was the other one, spades. So actually, in the order of precedence for these, spades is considered the highest suit, and then hearts, and then diamonds, and then clubs is the lowest of the 4 suits. But there is 1 heart, 1 diamond, 1 spade, and 1 club that makes up the aces. The thing here is that these 2 aces are included here also. So it's like we would get a double if we pick the ace or we pick the red card. Well, there's a double there. When that happens, when it doubles up, you actually have to go so far as to subtract the amount that are doubled up. So it's not just the 4 plus 26, you also have to do the minus 2. That's because 2 aces are repeated. And by subtracting it, you no longer have a problem with repeating it. So we have 4 plus 26 minus 2, which is 30 minus 2, which is 28. So we have 28 over the 52. which reduces to 7 over 13, which is acceptable as a decimal form as well. Now, let's do it where we have a variation of that, this time with the black cards, but also with face cards. So for face cards, each of the suits have 3 face cards, king, queen, and jack. So that means that there are a total of 12 face cards out of the 52. Well, black cards, that's half the deck, so there's 26 of them. But of those face cards, black cards, these are spades and these are clubs. And I'll put red for the other 3. So that means that 6 of them are repeated. The 3 spades and the 3 clubs are in this 12, and they're also in that 26. So what we need to do is subtract 1 set of them. Not both, but only 1 set, so that we're not going to have a chance of repeating a card that we actually picked. So we would have 12 plus 26 minus 6, which is 32. So we would have 32 over 52. And 32 for 52 reduces to 8 over 13. Which we can put as a decimal, and actually I'll give that one as a decimal. That's a 0.62 or 62%. The other one above it is 0.54 or 54%, all of which are acceptable, or any of which would be acceptable answers here. Okay, now, still almost the same thing, but another quick practice of it here is that if we pick a red card, which we know is half the deck, so it's 26 over 52, or sevens. Well, we know that there are 4 sevens, but 2 of those sevens are going to be red cards, so we're going to have to subtract 2 out of 52. So that's 26 plus 4 minus 2 is 28 over 52. That one, by the way, is the decimal 0.54. Yeah, 0.54 again. 28 over 52 was up there. Actually, that reminds me then that we can't leave it as 28 over 52. We have to make it 7 over 13, which is 54 or 54%. Make that really a 4. So let's look at what is next called independent events. For independent events, we are going to roll a die to get a number, and then we're going to roll it a second time. But whatever you get the first time has no bearing whatsoever on the second one. So the chance of rolling a 6 when we roll a die is 1 chance out of 6. And we're going to multiply that times the chance that on the second roll that we actually get the same, that we get a 1. So that becomes a 1 out of 36 chance. So think of it as a 6, then a 1. And the chance of getting that, you only have 1 chance out of 36 possibilities that you would get that. And here the difference is that you're multiplying these when they're independent events. Let's look at it with this one. The probability of an even, well, the probability of getting a 2 is 1 over 6. Of getting a 4 is 1 over 6. Of getting a 6 is 1 over 6. That's 3 of them. So the probability of getting even ones is 3 out of 6. Now greater than 4, we have 1, 2, 3, 4, 5, and 6. Greater than 4 means not using those, only 5 or 6. And that's 1, 6, and 1, 6, which is 2, 6. So we would have 2 times over 6, 2 times 6. And that means 2 times 3 is 6 over 36, which reduces to 1 over 6. So that means you actually have a 1 out of 6 chance of rolling and getting a 2, 3, 4, and then the next roll of getting a 5 or a 6. So if you did it in that order, of course. Now, the last example here is a multiple of 3, which would be 3 or 6, or an odd one, which would be a 1, 3, or 5. The fact that 3 is in there twice doesn't matter. There are 2 possibilities out of 6, or 1/3. And here there are 3 possibilities of 6, or 1/2. So we would have 1/3 times 1/2, which would be, again, a 1/6 chance, or about 12.5%. So about 12.5% of the time you could roll a multiple of 3 and then roll an odd one. Just like here, about 12.5 or so % of the time you would get an even number and then roll again and get a 5 or a 6. So it's not a great chance, but it is definitely a chance that that can happen there. Okay, so here what we've looked at is when we are doing mutually exclusive events, not mutually exclusive events, and then independent events. So these are good examples to look at to get comfortable with when you see the wording of something to know whether you are adding and subtracting or multiplying. And that finishes the notes I have for the probability section for 10.7. Hopefully this and the first video were helpful, and thank you for watching.